So I'm back for my yearly upload. Today I'm doing something a little bit different. I'm not going to be talking about drones or cameras for the first time in a video. Now, I've been stuck inside for a while now, so I've been doing a lot of 3D printing recently. Without a doubt, one of the most popular 3D printers on the market is the Creality Ender 3 and its re-releases and its clones. The main reason why this printer is so popular is because of its giant community surrounding and supporting the printer. The machine in its stock configuration is really capable, but the fun really begins when you start looking at the community mods and customizations you can do to change your Ender 3. So in this video, I'll be going over my favorite upgrades that I've done to the Ender 3 without breaking the bank. So to start things off, the most infamous part prone to failure on these Ender machines is this right here, the plastic Creality extruder. This thing can cause a ton of headache if it's not properly addressed before it breaks. Notice how I don't say if it breaks, because all these plastic extruders have a limited life on them before the plastic itself will snap. This right here is actually my second extruder from Creality, since my first one, my arm had snapped after only a month of printing. Now, a very common upgrade that a lot of people might do is to get one of these red dual gear extruders off of Amazon, because these are drop-in replacements for the plastic one when they fail. But I've actually had a lot of issues with this red dual gear extruder. This happened to my own extruder, and it happened to other people that left reviews on this page. The metal gears end up grinding away at the aluminum frame of the extruder, which means that eventually it'll just stop working on you and fill up with dust. So for a permanent solution to the extruder problem with these Ender 3s, I've gone with a dual gear extruder by Triangle Labs. This type of dual gear extruder from Triangle Labs works very similarly to the red aluminum ones we see on Amazon. It has one gear driven by a motor and a second gear that helps push the filament. The main reason I decided to go with this one instead of another red aluminum one is because this one will not eat away at itself and eventually self-destruct. I picked up this extruder in a kit with an all-metal Hotend, which I'll be talking about next. So the next upgrade I've decided to do is to fully replace the Creality style Hotend. I've chosen to fully replace this because I wanted to print with higher temperature material, and the main flaw with the Creality Hotend is that it has this Bowden tube running all the way down to the nozzle, which will start to burn at around 240-250 degrees Celsius. So instead, I've swapped it for this all-metal Hotend by Triangle Labs. Building and attaching this Hotend on my Ender 3 was really easy and fairly straightforward. The only piece of advice I have if you are going to go with this Hotend is you do have to follow their settings. You'll have to change the retractions for PLA. I know with a Hotend like this, I was using around 6mm of retraction, but I've had to bump that down a lot to around 2.5mm at 80mm a second. After that, I had no jams, and this Hotend has been working really well ever since. In all honesty, once you know what you're doing with an Ender 3, leveling the bed is not very difficult. One of the things that leveling a bed can't fix though is a warped bed that has high points and low points in it. So this is where a budget 3D touch sensor can really come in handy. This 3D touch sensor in particular is very similar to a BL Touch. It has the same wire configuration, has the same plastic casing, and even has like the same sort of retracting pin. The main difference for this sensor is its price. This one only costs $14 shipped from China, whereas an official BL Touch can run up to around $45, $46. Installing one of these bed leveling sensors can be a lot trickier if you've never touched 3D printer firmware before, so I would do some research before going into it. So when all set up, how does the 3D Touch perform compared to the original BL Touch sensor? In my testing, using the Clipper firmware, I was able to run a command called probe_accuracy. I did this both with the clone and the original BL Touches. So I'll put the values up on screen, but basically both are very, very accurate sensors that will be perfectly capable for 3D printing. Technically in these tests, the clone did a better job having a lower standard deviation than the original BL Touch, but they are so close and the margin of error is so small that I would say that they're both equally just as accurate. The only other thing to note for the clone BL Touch and the original one is the original can come in a nice kit with a metal mounting post and the proper wiring for hooking up to an Ender 3, whereas the clone doesn't come with these extra accessories, so you'll have to 3D print your own mount and you'll have to do some of the wiring yourself. So the next upgrade I have is a very nice convenience upgrade towards the Ender 3, and it's a Raspberry Pi. I'd recommend going with a Pi 3 or newer. The Pi 02 is also a good one. These Pis can be a very nice convenience upgrade and can save you a lot of time when it comes to printing. Instead of having to slice, put it on a SD card, eject, and then load it into a printer, you can upload a file directly from your computer and send it off to your Octoprint on your Raspberry Pi. So I've chosen to go a step further with my Raspberry Pi setup. Instead of running Octoprint with the stock firmware on an Ender 3, I've chosen to run Clipper on my Ender 3 and use the WebOS Fluid on my Raspberry Pi. The Clipper firmware and the setup I have going on is definitely for more advanced users and maybe shouldn't be the first thing you jump into. However, the convenience features of being able to modify your firmware directly through a web interface is very useful and has saved me a ton of time already. Not to mention the advanced features has, such as input shaping and pressure advance. This can give even better print quality to a cheap machine such as an Ender 3. These next two upgrades I have aren't exactly a necessity, but they are nice if you have the extra budget for your printer. The next upgrade I would suggest for your printer is a new upgraded mainboard. The mainboards that Creality is shipping on these newer Ender 3 models are a lot better than the older ones. Those used to be 8-bit boards, where these are 32-bit. They no longer require bootloaders, and they're still very capable, but they don't have silent stepper drivers. So I've chosen to go with the Big Tree Tech SKR Mini E3. There's a version 2 and now a newer version 3 out, but either works practically the same. I'll put up a sound test so you can compare for yourselves, but the difference it makes to have these silent drivers is really incredible. Another benefit of this SKR board over the Creality boards is that it has a second Z-axis connector on the main board. However, this isn't independently driven, so it's using the same driver as the first Z-axis. So when you plug it in, it'll basically just run exactly the same as the original. So you can't do anything fancy like Z-axis tramming with something like a more expensive board. So the last upgrade I'll talk about for the Ender 3 is a dual Z-axis upgrade. This can be done in many different ways, but I think it would be best to have a second Z-axis motor and a Z-axis rod. That way they're both independently supported on both sides. With this upgrade, you might not see a significant improvement in print quality, but what it will do is take stress off the rollers on the unsupported side of the printer by instead introducing this rod, which will help keep it from sagging. So if you decide to do a dual Z-axis upgrade on an older Ender 3 or Ender 3 Pro machine, you'll need to find a new space for the power supply. I've relocated this to underneath the printer on my own Ender 3 Pro, and I'll have a link for that in the description. So these are the main upgrades I've done to my own Ender 3. So if there are any upgrades that you think should have been on this list, let me know in the comments. So with that, thank you all for watching, and I'll see you in the next one.